And wait for the little red light to come on. And there it is. Yeah, but Krieger is the scientist that's a robot that does crazy things in his lab, if you don't know. So every time I see your name, Miss Krieger, I think about that. And if you hadn't watched Archer, it's hilarious. I love it when he goes like he don't know what's going on, which is most of the time. It's just so funny. I get that a lot. It's a good. It is. It's hilarious. I hate that. You know that Mallory, she's dead. You know, the lady Jessica Parker, she died. So I hope they get somebody like they ought to get Betty White to do Mallory. Betty White would be hilarious doing Mallory. Don't you think, Betty White? Okay, I'll shut up. I'm gonna get a few words out of y'all, and that's all I'm gonna get. So I might as well just get what I can get, right?
What show are you talking about, Hubert?
It's called Archer.
I don't know if I've ever watched
it's an
it.
animated show, and you got to watch it from season 1. Okay, I think it's on FX. I don't know. Does anybody know which one it streams off of? Hulu or I quit on Netflix, so I don't know about Netflix. But I watch it when it comes on regular TV. I just record the series, and that way when it comes on, I just watch it.
I think it's on Hulu.
It's on Hulu. Yeah, and it's called Archer, and it's hilarious.
Hubert, what's your beef with Netflix?
I just better stay away from that. I'm gonna teach calculus. I'm just gonna stay away from Netflix.
I understand. I feel the same way.
What?
I said I feel the same way. I don't really mess with it that much either.
I actually have been with it since it first came on, and they had Andy Griffith, and they took Andy Griffith off, and that's one reason I dumped them. And the other reason I dumped them was they were creeping up in price, and the third reason I dumped them is because I don't like some of the people that they bring on as far as TV shows and stuff like that. So anyway, here's the first one. It says find the derivative. And of course, most of these are going to be find the derivative. So I'm just going to put derivative. And A is equal to 510 times 1.638 to the t power. Now, I don't know if y'all noticed this when I sent this call. Right before I sent the call, I sent y'all a sheet. Looks like this. Did y'all get that? I just put 2.6. The formula's out of 2.6 on there for you. You're welcome. And I showed you that the other day in the slides, but I know some of y'all probably didn't write them down, so I just put it to you on a sheet. So you might want to print that sheet out and put it beside these problems when you're doing them. You could actually say this is f of x is equal to 510 1.638 to the x power. You could do that if you wanted to. I find it a whole lot easier to work with x, but that's whatever you want to do. Now this looks like this looks like the exponent right there, the exponent. So the first thing I'm going to do is I'm going to pull that 510. What is 510? That's just a number, right? So I'm just going to pull that 510 out. And you need to start getting used to this, because when we get to antiderivatives, you're going to pull the constant. That's a constant. That's a number. I'm just going to kind of pull it out and put this in parentheses. Or brackets, whatever. Now, this is what I'm going to take the derivative of. So this falls along the derivative of a to the x is equal to a to the x times the natural log of a. Okay, and I just wrote it like that. That's not the way it's usually written, but I just wrote it like that. So I'm going to take the derivative of this right here because this is just a number. Now, you could do the product rule right here and do first times the derivative of the second plus the second times the derivative of the first. And what's the derivative of 5/10? 0. It cancels out the whole second term, and you're left with this. So you could actually go through and do the product rule and see why this comes out. But if you did, you'd see that that second part would cancel out with the 0, and you'd just be left with this. So f of x, f prime of x is equal 5/10 brackets 1.638 to the x, 1.638 to the x, times the natural log of 1.638. Now, if you wanted to put that 5/10 with that natural log, you could. That's up to you. You could write this many different ways. 5/10 natural log of 1.638 times 1.638 to the x power. That's one way you could write it. That's about it. I probably wouldn't. You could put this in parentheses. You could put this in parentheses like that. So that's basically the answer. So that's a good test question. Any question on that one?
No, sir.
Okay. Pretty straightforward. And like I said, on these derivatives, I try to put you straightforward. I don't try to trick you, and I don't try to give you a Philadelphia lawyer question. That's why I didn't like that question the other day, because they skipped a couple of steps. And even if you go into your book, I even looked in your book, and they don't do a good job in your book. So I'm going to try to go over that problem here in just a few minutes. Here we go. Differentiate. Y is equal to 2 to the x to the 8th power, 2x to the 8th power, plus 10. Now, the first thing I'm going to do here, does anybody know what I'm going to do first? Anybody? I'm going to put that x to the 8th plus 10 in what? Why am I putting it in parentheses?
Is it one term?
I'm going to put it in parentheses because you got to remember to take the derivative of what's inside. This isn't 2 to the x power where the derivative is 1. This is 2 to the something something where the derivative is not 1. It's what, 8x to the 7th power? So you've got another part to this problem. It's a 2 to the x, okay? But you've got, let me show you what I'm talking about. If I give you a regular y is equal to 2 to the x power, well, there's a 1 right there, right? And if you did it by the chain rule, you would do, well, let's see, that'll be 2 to the x, y prime is equal 2 to the x times the natural log of 2, and then you just stop, because what is the derivative of 1x? 1, Hubert. So you're supposed to take the derivative of what's inside, but since 1x is x, we don't do that. So when you get to a problem like this, you have to do the same thing. You have to take the derivative of what's inside, and you have to take it right here. So here would be y prime is equal to 2 to the x to the 8th plus 10 times the natural log of what? 2 times what? Now we're going to do in this right here, put it in x to the 8th plus 10 in those pink parentheses, because you need to do, this is the chain rule. So now I'm going to change that x to the 8th. What is the derivative of x to the 8th plus 10? Thank you, class. And now I'll put the rest of it together. And you could put that anywhere you want, because this is all what? Multiplication. 2 times 3 is the same as 3 times 2. But I like to put that right there. Whatever I get here, I like to put it in front of that. And I don't like to put that under this. So I put this one last. So I usually write mine 8x to the 7th times the natural log of 2 times 2 to the x to the 8th plus 10. That's the way I like to write mine. You got to be careful. That's why I use those pink parentheses whenever I see something other than x. So if that was a 2x, I'd put pink parentheses around it. If this was a 1/2 x, I would put pink parentheses around it. The reason I don't do this is because people don't take the derivative of 1x, because it's the multiplicative identity, which means 1 times anything is anything. So we don't do this with the 1x. But anything beside the 1x, you need to put some kind of parentheses around it, so you'll remember to do this step right here and right here. Question, gripe, complaint. Do you feel good about yourself? Hopefully you do. So you don't have to put on too much makeup. All right, next one. Differentiate. Y equals log base 2 of x. Now this is your other property. And I'm going to put a parenthesis around this, because I'm going to make sure you remember to take the derivative of what's inside. In this case, it's 1. So let's look at our, I keep hitting the wrong button. There it is. So write that down if you haven't printed it out yet. Who else would make a good Mallory besides Betty White? Trying to think of an older type lady.
Hubert, what are you munching on?
Sour Patch Kids.
Breakfast of Champions.
Yeah, actually I already had breakfast. I just didn't have anything to snack on, and my son had these on the counter, so I grabbed a bag and put over here. All right, so here we have log of 2 So let's write it over here. Let's write our formula. I'm going to write it over here so you can see log base A of x equals 1 over natural log of A times 1 over x. And then you can consolidate it. And I told you before that basically this is derived from the change base formula. And if you do about a half a page to a page of derivation from the change base formula, you can get this right here. But it's just easier just to say, just take my word for it. All right, so there's our base. So we're going to have 1 over the natural log of 2 times 1 over x. And what is the derivative of x? The derivative of x is what? 1. So I want you to get in the habit of doing that, because if this was 2x plus 3, then you would take the derivative of 2x plus 3, and it would be 2. And that 2 would be multiplied over here, and that would be 2 over 2x plus 3. So you got to remember to do that. So y prime is equal to 1 over x natural log of 2. You could actually put this up here, and that would be 1 over natural log of 2 to the x power. You could do that. So somebody tell me what rule I used to go from here to here with logs. Not the product rule, but the what?
Is it quotient rule?
The what? The quotient
Never
rule,
mind.
did you say? No, it's not the power rule. I'm sorry, I just told you. Power rule. When you take the x and put it up here, that's the power rule of logs. Okay, that's number 3. I've got about 6 to 8. Well, that's chances are that's how many you're going to have on your test. All right, let's try another log. G of x is equal to log base 51 of 8x minus 7. I'm going to let y'all do this one. And then we'll do it together.
Is that 8x minus 7 above the 51, or is it beside it?
This is the base. Base is 51.
Okay.
So this is just regular notation. So my base is 51. So that means 1 over the natural log of base, 1 over natural log of 51, times 1 over 8x minus 7. And I'm going to put parentheses, green parentheses, not pink. And what is the derivative of 8x minus 7? 8.
8x to the 7th.
I'm sorry, what?
Oh, never mind. I thought it was an exponent. It's just
Should
x.
be
It's
8.
just 1 or 8.
Yeah. So now you just do a little bit of simplifying, not much, because the only thing you can do is pretty much put this on top, 8 times 1 times 1. So g prime of x is equal to 8 over, and I'd rather put this out front of this, 8x minus 7 times the natural log of 51. And technically, you could put that 8x minus 7 up here. I'm going to write that, but I doubt very seriously that they want that, because usually you don't want to have the 8x plus 7 minus 7. You don't want that as a exponent. So this is probably your answer right here. But if you wanted to get fancy, you could do 8 over natural log of 51 raised to the 8x minus 7 power, using the power rule. So by bringing this back here right there, you get that. So probably this is your answer, but you could write it like that. The only reason you really don't want 8x minus 7 in the numerator, I meant the exponent. All right, let's put some product rule in there. Let's see if we can do some product rule with it. How about y is equal to 4 to the x power times log base 8 of x. And of course, you got two terms with a variable in it, so you're going to have to use the product rule. So go ahead and get started on it. Dogecoin's at 13 cents. Got up to 14 yesterday. I just wish it would get up to like $100 and I could retire.
I didn't know you'd leave us that easy.
What?
I didn't know you would leave us that easy.
It's going up. If it would hit like Bitcoin, I would never have to work again. $60,000 a pop. Woo!
Oh yeah, I meant to ask. So
I'd be a billionaire. What?
You have money in Dogecoin yesterday?
Yeah.
Oh, you must have been a good day then.
Yeah, 14 cents. I did pretty good, but I wanted to get up to, if it got up to 10 or 15, maybe $25, I'd be real good. But they're saying that once it hit Coinbase, see, the only place you can get it now is Robinhood. But Coinbase is fixing to carry it. And when Coinbase carries it, a lot more people are going to buy it. And it should go up even more. I can't believe that I bought stock in it and it didn't go down. That's usually what happens to me. When I buy stock, it goes down.
Isn't Dogecoin the one that Elon Musk supports?
Yes.
Well,
And
he's gonna
Snoop Dogg
make
and
sure
Mark
it's all right.
Cuban. Huh?
I said he'll make sure it's all right.
I hope he does. I wish he'd put it in that one of them SpaceX. Put Dogecoin on the side of it. Actually, him, Mark Cuban, and Snoop Dogg, actually, and a lot of the Mavericks basketball players endorse it. So, yeah, but, you know, Bitcoin's at 60,000. I mean, I'll take half of that, 30,000. You know, I'd be glad with 30,000. It's so tragic. I have like 5,000 in Dogecoin as joke savings account while in high school and sold it. Oh gosh, you're kidding me. Oh, that's kind of like when I worked at Walmart. Right before I went to the Marine Corps, I worked at Walmart a couple of years, and I bought like a lot of stock in Walmart. And of course, being the know-it-all teenager I was, I decided to sell it. I should have left it in there while I was in the Marine Corps and left it in there another 10 or 15 years, and I probably could have retired off of that. But the reason I didn't sell this is I bought it kind of like you're talking about, Miss Krieger. I kind of did it just to do it. It was at 0 cents. I mean, you could buy like 5,000 shares with like $6, and that's why I did it. And I bought like, I don't know, 40,000. And I'm hopefully, I just want it to get up to like $100. If it got up to $100, I'd be set. All right, so first times the derivative of the second, and I'm going to take my pink pen plus the second times the derivative of the first. Take my green pen and y prime. Y prime is equal to 4x. Okay, let's see, that's going to be what? That's going to be 1 over the natural log of 8 times 1 over x, and then the derivative of x is 1. So I'm going to put 1 over the natural log of 8 times 1 over x, and then times 1. I'm just going to say times 1 because the derivative of x is 1. So that's just multiplicative identity. Plus log base 8 of x. Now, how do I do this? Well, the derivative of 4 to the x is 4 to the x times the natural log of what? Hold on a second, I got something in my eye. Times the natural log of what? Go back to your handy dandy, since you're not talking.
Is it
be
8?
4 to the x, natural log of 4, right? Yes, Hubert. Thank you. Natural log of 4. Now, your calculus is done. Only thing left is what? Algebra, or simplifying. So I'm going to take my handy dandy black pen now that I've done everything calculus-wise, and I'm going to go y prime is equal to 4x over x natural log of 8. I'm not going to do anything to this. Plus 4 to the x natural log of 4 log base 8 of x. And the x's cancel here. Get my red pen. X's cancel there. And I think that's it. I don't think you can do much more. So I get y prime is equal to 4 over natural log of 8 plus 4x natural log of 4 times log base 8 of x. Now you could put that 4 to the x up here as an exponent, but I just leave it like that. Oops, I made a mistake. That's 4 to the x. My bad. And you can't cancel, so that would be 4 to the x. My bad. Be careful. You can bring this x down and put it right there like I just did. Try not to do that. I messed up. I looked at the answer and I'm like, oops. So this is the answer. I think I got one more good meat and potatoes derivative. And that is g of x is equal to x to the 9th times 10.3 to the x power. Or the x can be outside. It's basically, it's going to be the variable. So you could write the x on the outside. It doesn't matter. G of x, x to the 9th times 10.3 to the x. You could write it like that. You're going to have to use the product rule again. Give y'all a couple of seconds to work that out. So, Miss Krieger, when you bought it, was it like 0 cents? You remember it was like 0 cents or 1 cent when you bought it? She's probably not going to reply. She don't want to talk about it. I don't blame you. That would have been an easy $700 to $1,000 depending on when you bought it. Yeah. If it would just get up to $100 for each, oh yeah, that would be like hitting the lottery. But the powers to be don't know. See, what the problem is, they don't know that I bought some yet. When they get down to who's bought some and they see Hubert McClure, well, that's when Dogecoin is going to just drop down to zero. And nobody's going to say anything. Okay. I must have pepper on my eyes or on my fingers or something. I'm cooking breakfast this morning. My eyes are burning.
What'd you cook?
I'm my cousin Vinny man. I cook eggs and grits. Eggs and grits.
Do you like biscuits and gravy?
Oh my gosh, yes. But I
Same.
need to
It's
stay
like one
away
of my
from
favorite
biscuits and
breakfast
gravy.
meals.
I grew up on biscuits and gravy. And biscuits and molasses. Unfortunately, it's your parents' fault. Some of y'all don't even know what biscuits and molasses taste like. But it's your parents' fault.
Have you ever had buttermilk with your biscuits?
Yeah.
Like
I mean,
real
also,
buttermilk?
I'll tell you what's best with buttermilk and cornbread. And
Oh, yes.
put some onions in there and some hot sauce and some salt and pepper. That's good stuff. All right, so first times the derivative of the second plus the second plus the second times the derivative of the first and now let's do our thing with the derivative. So that's going to be g prime of x is equal to x to the 9th. And what is this going to be? 10.3 to the x times the natural log of 10.3. Correct?
Yup.
Yeah. So natural log are 10.3 to the x times the natural log of 10.3 plus 10.3 to the x times 9x to the 8th. And I'm going to write everything. G prime of x is equal to, well, there's nothing really you can do. X to the 9th, 10.3 to the x, natural log of 10.3. Now you could change that to a number and put that out front with the 10 but plus 9x to the 8th times 10.3 to the x. I don't think they're going to factor out anything. Let me see. No, they didn't. They didn't even take the natural log of 10.3 and put it out here. But you could. What's the natural log of 10.3? natural log of 10.3 2.33. So you could, and I'm just gonna, that'd be 2.33 x to the 9th, 10.3 x plus 9x to the 8th, 10.3 x. Now, if you notice right here, you could actually, yeah, you could actually combine like terms here. No, you couldn't, because that's x to the, but you could say 2.33x to the 9th plus 9x to the 8th, parentheses, 10.3 to the x. You could do that because these are the same base, and I'm just telling you that. This is the same combined like terms. Those are the same. So you could put this plus this in parentheses times that. You could do that. So there's 3 or 4 different formations of the answer here. Question. Okay, now that is 10 point, that's 2.6. That's, like I said, that's the meat and potatoes. That's the derivatives. Okay, now I've got 1 or 2 questions over here that I want to put to you. Let me see if I can find which one I want to do first. My eyes will quit burning. Yeah, I got 3 problems here. Now, one problem I told you that is pretty self-explanatory is the interest problem. And let me find that one. Well, this one's kind of like it. This one says, following the birth of their grandson, Doug and Andrea, and I think we did one like this, wanted to make an initial investment that will grow to $10,000 for their child's 20th birthday. Interest can be compounded continuously at an annual rate of 8%. I'm sorry, 4%. Did we do one like that?
No, I don't think we have.
Well, remember, if I had my choice, I would give you questions about A is equal to P times 1 plus R over N raised to the NT power, and A is equal to PERT, P-E-R-T. Those are the 2 type problems I don't mind giving you on a test, because these are 2 problems that you're going to see, and these are both gains. So these are both, you know, gaining, and you will get one of these on the test. So this one is continuously $10,000. They want $10,000 at the end of 20 years. P-E to the point, was it 0.4? Yeah, 4% interest, 20 years. Okay, they want $10,000 at the end of 20 years at 4%. So all you got to do now is just solve for, divide this by e to that. So 10,000 is equal P E, well, 20 times 0.04, I did it right here, is 0.8. And then divide both sides by 0.8, e to the 0.8, e to the 0.8. I'm going to have to come off the bar rescue a little bit. I'm starting to have dreams and nightmares of firing people in the bar. So I got to come off the bar rescue a little bit. I know that's out of left field, but So e to the 8th, that's P is equal, and I'm going to take 10,000, and I'm going to divide it by parentheses, E second natural log 0.8. So what does what does he have to put in the bank? So at the end of 20 years, I thought I did this for y'all. He wants $10,000 for his grandson or grandchild, whatever. He's got to put about $5,000 in the bank, or $4,500 at least. So I thought we did this problem. 4493.28. Well, I would say that's the answer, but you'd want to put 4,500 or 5,000 just to make sure that you cover it. So 4493.28 is what Grandpa needs to put in to have exactly $10,000 at the end of 20 years, locked in at 4%. Of course, if you did 4,500 or 5,000, it would be more than 10,000 when you got through. Now you could do that for 100,000. You could do it for $1 million. You know, now remember, the more simple the formula, the less accurate it's going to be. That's why we had the savings. You have savings plans formulas that, you know, take up a half a page because they're a little bit more accurate. Okay. And of course, this would come out of the review section. That review, I think 2.1 or 2.2. Let's do one like this. Principal, let's say for giggles that Dogecoin hits and I get $4 million. Well, what's the first thing I'm going to do? I'm going to put that money in the bank, because by the time I figure out what I'm going to do with it, I could already raise a lot of interest on it. So let's say that the banks come back, and since I'm putting $4 million in the bank, they're going to give me an R of 6%. And I'm going to keep it in there for 1 year till I figure out what I'm going to do with it. Well, a lot of people say, well, Hubert, why don't you buy your car? Listen, if you put $4 million in a bank, especially a local bank, can you think you can go get a car loan with that bank pretty easy? Yes, Hubert, you will. Yes, you can get an unsecured loan or you can get a secured loan. With $4 million in the bank, that bank's going to let you borrow enough money to buy a new car. Okay? So you don't have to take the money out. All right? And we're going to leave it in for 1 year, and they're going to compound it monthly. So that's going to be $4 million times 1 plus 0.06 over 12 raised to the 12 times 1 power. So I take my handy dandy calculator and I work it through there. 0.06 divided by 12 plus 1 raised to the 12th power multiplied by 4 million. So at the end of the year, minus 4 million, I got $246,711 to play with. So I can, figure out what I'm going to do with $246,000. I could have $4 million and $246 million with a couple of bulldozers, a couple of tractors, a hay baler, and it'd be gone. It'd be gone, and I could spend $4 million probably in a week. Question, gripe, complaint on that one? All right, well, my eyes are hurting, and I've went over about, I don't know, how many questions did we go over, including these two? I think we went over about 10 questions today out of 2.6, or 8 out of 2.6. So you should be able to work on 2.6 a little bit easier now, and we will work on some more word problems probably Tuesday. Probably finish up and have a test Tuesday in the class, meaning a review test. Question, gripe, complaint?
No, I think we're good.
I appreciate y'all being so, communicating today. I appreciate it. Y'all settle down, and I hope y'all have a good weekend and not, get in trouble with, running your mouth too much. See y'all.
Bye, Hubert. I hope you have a good weekend.
You too. Bye-bye.
Thank you. Have a good one.
Bye, Hubert. Have a good
See
weekend.
ya. You
Bye.
too.